of all, thank you very, very much for the opportunity to be here. It's an honour to be here, and I hope I can say a few things which, tell a story about my life, things I've learned, things that have worked and haven't worked, and how I see things now. So what are disruptive discoveries? It's a bit of a funny word. It kind of implies you're doing something different. I think it's a pretty simple concept, Basins, as they mature, they cream. In other words, first discoveries are big, and then they get smaller and smaller and smaller. So how do you change that? Because what you're after, at least in some of your exploration portfolio, is the chance to jump up, to find another set of big fields. And it's kind of nice to name things. If you don't have a name, it's difficult to go and look for them. So this is the word that we've started using quite a lot in our company. I don't think it means that this is going after frontier, high-risk things at 10% chance of success. No, I think it's about going into basins where there's already seismic and well, all that coverage, but it's making the critical observations that people haven't made before. And a lot of that comes from understanding what some of the analogues around the world. So I'm going to talk about some of the analogues. It's difficult to do, more so in bigger companies, because you need to introduce a new idea. So I'm going to end with, how would you do that in a way that's constructive? How could you, stay a rebel, think about, bring new ideas to bear, but do it in the context of a company, an oil company. So I'm going to talk a little bit about things I've seen which have struck my eye. I think chasing carbonates in proximity to clastics. I seem to recall back in the day that if you were anywhere near delta, there weren't supposed to be any carbonates around. I'm not sure that's true. I want to talk a little bit about heat flow. I think I always wanted to be a basin modeler. I'm definitely not a basin modeler, but I'm fascinated with the concept of heat flow. And that's moved on from all those years ago when we were talking Mackenzie model and thermal substance. And then something that I've been lucky enough to work on is looking for some of the high net to gross elements in deep water basins. And so much of the US GOM is about that. So how do you go looking for high net to gross spots? What should they look like? Different parts of the basin. Let's see if I can get this pointer to work. There we go. We're going to go around the world a bit. And we'll look at some of these things and think about whether they could be relevant. How could they be relevant to the US GOM? Doesn't work, does it? If I point to that, maybe. So, carbonates next to clastics. Kind of got that here. Florida Escarpment isn't that far away from Louisiana. But they can get really intertwined. I was working in BP and in Egypt, they got me to do a set of regional maps for the southern Gulf of Suez, which was Amoco BP at the time. And I started really realizing that to fit the well control, I had to put carbonate reefs next to clastic inputs. I mean, hundreds of meters apart. And that's what you see if you go there. Onshore you have all these alluvial fans and braid plane systems, and you step straight into carbonate platforms around all of these islands. So that got me thinking, and that led me to probably one of the biggest lessons of my life, which was associated with working the northern Egypt and working the Nile Delta at a time before Zohr was found. So what is Zohr? Zohr is an isolated carbonate platform just off in front of the Nile Delta. And it was a play that was known about, but it wasn't being chased. If you go to the Mediterranean on holiday today, there aren't any active reefs. But if you go pre-Messinian, there's all sorts of Miocene carbonates, Eocene carbonates, Cretaceous carbonates systems. And just in front of the Nile Delta, even today there's a big, what they call a seamount, but it's not. It's an isolated carbonate platform called Eratosthenes. and you look at seismic lines across that, you can see all of the progrades, and it's classic. And Zohr was as small as Eratosthenes, happened to be covered in salt, and sure enough, you know, E and I pointed this out on 2D data. They drilled the well, 22 CF, hundreds of meters of karstic, well, not karstic porosity, but really good carbonate porosity. But that was pretty cool. My problem is, previous to that, I'd been running a regional team for BP in the Nile Delta, and my job was to go through the stratigraphy from the Cretaceous to the surface and draw reservoir maps and describe play systems. And one of the play systems I described was the Eocene carbonate buildups. So I described it. That's my play cartoon, which was used in the E&I paper later. So I feel really bad about that. I put it down, I made maps of it, but why didn't I was a senior advisor in BP at the time, a technical advisor, why didn't I ever talk to someone about this cool play? Do you know why? Part of it was my role, was at the base of something called an exploration triangle, and I was supposed to be providing the regional framework so that the people at the top of the triangle, the prospect explorers, could have done all the pieces that they had to do to get something approved. I didn't see my role as pointing out there was a potential disruptive discovery there. And I think that's why I'm so happy that I put a name to these things. If you name it, you can go and look for it. Does that make any sense to anyone? So I kind of feel personally responsible for that in some way. Yeah, it was on 2D. I can understand why it was a difficult drilling decision, but boy, that was disruptive. And there are more of those out there. I've seen them on the seismic lines. I don't think they've been drilled yet. Do we have that play in the US GOM? We sure have a carbonate platform to the east of us, northern GOM, and we sure have it in the south. Where would it be? Well, I think, you know, I can put I don't think it's on the Florida platform because there's no intervening seals, but could it be in front of it? Could there be isolated build-ups there? And you can kind of see where you take the Stewart Reef trend and you extend it offshore, you're going into more accommodation space, so they could get much bigger. And if you were being relatively naive about it, you'd use something like this, which is an isolated build-up from the Far East, to go looking for them. I think you need to be a little bit more reflective on what it would really look like. These build-ups, if they exist, will be over salt-cored structures. And if you read any of Andy Horbury's work, he's worked a lot with Pemex as a carbonate stratigrapher, the process of salt movement would brecciate some of these platforms. But they'll still be there as breccias. The breccias will be just fully platformal. There won't be reworked slope carbonates. So I'm intrigued by that. And we're working in an area, well, we've talked about, you know, we got into the Hudat concession. There is potential for that sort of, at the sort of late Cretaceous stage for exactly that play in there. And it has have a strange seismic look to it, but that's a pattern to go looking for. What else can we go to? Pre-salt. The pre-salt story offshore the Santos was fascinating. People didn't realize that salt cooled underlying rocks. So it was always seen as a deep gas play. And of course, back in the day, before 2P was discovered, the seismic imaging was awful. But you could see these big blocks. 2P was drilled, much cooler than they thought. And therefore you had two things. You had oil instead of gas. Although I think I've been told there's gas beyond it in the outer Santos. Not sure how much I believe that, but I've been told that. And also your carbonate, your sort of freshwater lacustrine carbonates had much better pore perm than people thought. So big success, and it's gone and gone and gone. People didn't really like it because they didn't see that you could use the ADO tool there. But there are pre-salt discoveries that have flat spots. You know, in carbonates, your water cements up the rocks, and oil it doesn't. So you can see these things. You see that in the Middle East as well. Really interesting. I don't know if we've got that there. I don't think we've got it here. But there's a fantastic guy called Frank Peel, who on the APG website, there's a video of him giving his talk. And he was given a regional data set by TGS, and he mapped pre-salt, pre-mother salt. And this is the map that he created. And I don't know if you can see it, but so can you see the fact there's some sort of highlands here? So this is mapping under the salt. There's the salt, and you come up, and it's this surface is mapping, the top of the pre-salt. This is the stuff. So you can see there's some highlands. They have a shape that looks as though they look like things off Mars, you know, hill forms. And then you can see a big river system that comes in. It's coming out of the Central Atlantic and coming into what would have been an enormous lake at the time before the salt was deposited. And you can see, if you look really closely, at all of these river systems in here. He also pointed out that there's a point where you go from an eroded topography to a smooth topography. Do you know what that is? That's where you go into the lake. So pre-salt, there would have been a lake full at that time. So there are lacustrine turbidite, presumably, down dip at that point. And there are probably sand dunes sitting up dip at that point, sealed by salt. That's a pretty cool play. Hypersaline lake. Could you put carbonates in there? You possibly could. But that's a fantastic map. And where is that? Well, he fortunately was able to, in his presentation there were some log boundaries in there, or quadrant boundaries. And this is where those freshwater turbidites potentially are, or whatever that system is in the lake. That's Mississippi Canyon, as far as I know. You can't go onto ocean floor, so there's a real edge to it. But that's not a bad place to go in looking for sediments that are coming from a completely different direction. You've got to go pre-salt, it's a long way down, but you know, technology takes us deeper and deeper. So if you want to see a really cool video, Frank is a fantastic speaker. You know, that's one to see. Heat flow. So what's going on in Namibia? I've been following that a little bit. I mean, it's not an area we even look at really, but I've been looking at it in publications and conferences. And it's an area where you have had unexpectedly high heat flow right at the base of the passive margin as it steps onto oceanic crust. So I was taught back in the day that, you know, you have a rift episode, which looks like this, then everything cools down and you get a big longhorn passive margin basin on top of it. So in sort of heat versus time, you know, always it hot when the rifting goes, but it gradually cools and cools and cools. And the closer you are to the ocean edge, or the front of the oceanic crust, or continent ocean position, the cooler it is. That's not true. Heat flow specialists have been saying that for years, but there was a dogma that was the case. There are places of anomalous heat flow. What's it due to? You know, plutons in the passive margin, sometimes transform systems or steps in the system, but it's definitely there. And this is a fantastic line. There's a really cool work of Katia Rodriguez, who used to be in Searcher. I think she's joined a company recently. She's done a lot on LinkedIn and presented stuff. This is the Venus fan and the Venus discovery, and there's been a discovery also in the upper Cretaceous up here. These are all SERs. This is a volcanic margin, and basically this is oceanic crust, this is continental crust. I don't remember being told you could go and explore an oceanic crust, but there's discoveries there today. Obviously you've got to drill in 3,000 meters of water, so there's a bit of drilling technology that helps you get there. But this is a definitely new play. That's what it looks like close in. That's what it looks like on a regional line. You know, that's the classic oceanic corrugated crust that Jim Pindell would show you. Jim would also tell you that as you go from continent to oceanic crust, you step up oceanic crust is more buoyant than continent. Do you want to see what this looks like in depth? Because that's a time section. That's what it looks like in depth. You actually go up dip out into the basin. You know, if you're looking at a turbulent system that's coming down here, it's going to pinch out somewhere in the basin. If you're going up dip in that direction, that really helps your track risk. I hadn't realised that at all. And I've heard some papers, I've heard some conferences that that's not really the case, the pinch out is up, coming back up here, but boy, that would be something to really go and look for. Could we do that here? Well, there's plenty of places where we go up dip onto oceanic crust in the US GOM. I never really thought that you could have a trap going up that way if you can put sands right at that limit. So I think that's a cool idea. I did work, and I have been working in an area of anomalous heat flow. I worked offshore Honduras for a small company called Caravex, and we found Pro-Sierra, a really nice eroded carbonate platform that sits in one of the sub-basins along the edge of the Guyana Trough, you know, the biggest transfer system in the world, extractive system in the world. But the problem with this play is it's not very deep, the basin. And when we try to talk about this to other companies, they're like, no way is that mature. Well, be careful. There are flags for hydrocarbons above the carbonate platform itself, and there are 53 seabed cores that have got some evidence of thermogenic hydrocarbons from the data. And the heat flow data is telling you it's 50 degrees centigrade per kilometre, not your classic 25 or 30. Actually, here on the platform it's more like normal continental crust, but here you get hotter heat flow. Okay, well that changes things. Hence it's been in my head, just be a little bit careful about heat flow. There should be, and there are places where it's different, and that can lead you to disruptive discoveries if you really put that together. Okay, so a couple of slightly, three off-the-wall things, but I think they're important to keep those in mind in terms of global analogues. What about going to look at the classic reservoir systems we're all used to looking at and searching for at the moment in the GOM? So when you get high net to gross is a really cool question. This is a cross-section by Mike Mayo. I like this a lot. I always think of slopes, and I might be wrong, but I don't think they're continuous or gradually gradients. I think you have an upper slope, which often sits in front of the clinoforms. Then you have a mid-slope where turbine systems are accelerating and cutting their way through mini basins down to the floor, and then you have a lower slope where things start to advance. But they still stays channelized, probably channelized all the way out, to the middle of the ocean. So Zama, Lisa, and Atlanta, which we just got into in Brazil, they all sit in this upper slope trend. They all have net to grosses from 70 to 100%, and they're all thick reservoirs. They're not bypass zones, but they have a very specific geometry. They're called sandy dendrites. I'm going to talk about that. Girasol in the early 2000s is the play that BP was chasing in Angola. Big incised systems, and then we kind of know what's in the lower slope. We've got that here. So let's talk about upper slope systems. They exist in the GOM because Zama is exactly that. They're not channelized. This is 1,000 feet, and it's 80% net to gross. And what they are is that I like to call them submarine landslides, which is a bit weird, but it kind of means it's just like you see a landslide and the thing goes off, but it doesn't become a turbulate, it sort of locks in place. And sometimes it even forms a depositional feature. Because it locks in place, it's thixotropic, so you get a lot of sand injection structures coming up through it. We saw that in the Happy Field of Egypt, see that in the North Sea, and that's what Zama is. You go and look at the core, it's packed through of injection features, It's packed full of shelfal fauna that's just come off, locked in slope. It is not a turbinate in 1,000 metres of water. So that's cool. I mean, you want to find one of those. Dave Cosmatitis and Talos published this, but there's Zama, and it's a bit of a strange map, but this is a sort of offshore Mexico. What's important about this map is here are the slope channels. That's the Durasol terrain, or topography. Zama's in board of that. And guess what? That's Starbroek as well. You know, all those fantastic fields offshore Guyana. I'm waiting for Neil to throw something at me. You know, they're pinch outs at the base of the cliniform. And what's providing the lateral seals are mud-filled channels that dissect that and form a series of these very high, high net to gross units. But they're right there, they're right at the upper slope. And so this play is a really important play. You know, strat traps up against cliniforms are usually quite risky. But what do we have these days? We have regional 3Ds. We get hints of flat spots down dip. You start to understand which ones to drill. You de-risk the stratigraphic nature of the plan. So could we go looking for those? Well, I think I know where they are. Just from published data, you get the feeling that probably this is the lower slope. This is mid-slope. You see the fingers coming out. The upper slope has to be between the shelf margin and this. Be very careful. Most of that area is sandy bypass, strings of sand. But if you can find that depositional topography, that sandy dabrite, you're into something that is very disruptive. It's going to be 80% net to gross. If it's anything like Zama, it could be 1,000 feet thick or more. So certainly this is a place that it's in the flex trend. So it's not that easy to get to. It's not where the latest seismic is being shot. But why wouldn't that play with that? Why wouldn't you go looking for that? When you see them, you can see them seismic. Step down the way. So step into the middle slope. If it's anything like Angola, you should have in places big incised channel cuts and then sets of sands that infill that initial cut. And you work your way through it and you get the best seismic. And sure enough, here you've got very thin sand with nothing in it. Here you can have very high net to gross stacked systems. But what you've got to do is not map the amplitudes per se. You've got to find that surface and find that and trace it and look for this. Massive debate back in the day, are the sands in the US GOM more sheet-like, fully mini basins, and Angola's a completely different basin? I was part of that, and I can't see why this shouldn't be there. I can see it on some of the seafloor images. And not only that, but my friend Hussein, that's exactly what Repsol and DEA drilled in the southern GOM. So all you've got to do is step to the other side of the basin, and this is the Pollock discovery, which is not a dirty word. Pollock is probably some Mayan god. But when you flatten this feature, and can you see the flat spot? CCR cutting through there, up against this salt thing. If you flatten it, there it is. Big incised systems that step up. Tiny footprint, 600 acres. There's probably 250 million barrels of recoverable in there. So they are there. It's proven in Pollock. Why wouldn't it be in the north? And again, where would it be? It's got to be in there, isn't it? We just got into Houdat. I've been looking for those inside canyon systems. I don't think they are there, but I do see lots of channel systems cutting through that. They just haven't amalgamated into a single canyon. But I'm sure it's there. And again, it's in the flex trend, hasn't got the best seismic data, but that would be pretty good to find. And then I'm really glad that Talos published a section over Danalis, which is a lower slope turtle. We looked at that We think it's a great prospect. And if you're going to go and look for high net to gross in the lower slope, boy, do you want to go to turtle structures. As long as you can charge them, that's where you pond science. So that well's, I think, coming up for drilling this year. That's going to be a really good one to look for. And that's, it's actually quite a long way down in the lower slope. Denali's it's even further down than how this map's drawn. So, disruptive things, carbonates and proximity. Think about heat flow. Think about looking for high net to gross further up dip than where we're exploring today in the GOM, or most of the industry's exploring. So, we don't have to read through this, but that's a really interesting concept, I think. Most companies are a bit wary of doing carbonates, but you can go deep into high temperatures, and carbonates dissolve in that case. They don't behave like tight clastics. I think this is really interesting. What does that mean? How localized is it? If you see data that says it's a bit anomalous, maybe it's right. And this whole thing about high net to gross, should give you some bigger pool sizes than you would expect. And a string of them. If you find a Zama in the, under the flex trend, boy, you're going to go and look for some more, and the industry will shoot seismic and OBN to help you do that. So I hope that's interesting. Linda asked me to talk a little bit about north versus south. I don't know how I'm doing on time, Bruce. Where are we? We're still before 8.
15 minutes.
All right, good. Okay. Why are all the companies exiting Mexico? And why are we still exploring and finding more stuff here? Is that the geology, or is that something else? So I'm a newbie to the US GOM, but I was so lucky to work in Mexico, both in BP and then well, it's kind of different in terms of its maturity. There are a lot more wells in the US GOM than there are in Mexico, offshore, particularly in the deep water. And this is a transform margin. This is another potential Guyana area. There's virtually no wells offshore there. And the other thing, which is so obvious when you think about it, is that the infrastructure is completely different. You have the luxury in the US GOM to go and look for things that are 15 million barrels in scale. You can't do that offshore Mexico. There's nothing out there. You've got to look for things which are 150 to get going. So you've got to find the hub class discoveries offshore Mexico, where you're at a completely different place in the US GOM with tiebacks and everything else. And the seismic is completely different. Wall-to-wall seismic of different vintages, different technologies, this new OBN stuff, that's all over the US GOM. The best we had in Mexico was multi-wires. It wasn't even particularly multi. It was like two things put together. And you've got the same subsalt challenges, so guess what? Getting your wells in the right place, subsalt offshore Mexico is pretty tough. Bob put this together. This is all the technologies that you could lever, in terms of understanding your velocity model, your image quality. You start with narrow azimuth, you move to wires and multi-wires, and then there's everything else going on. What have we got offshore Mexico? That's what you've got offshore Mexico. Can you get the wells in the right place? Probably not. This is what we're doing, thanks to TTS. There's a multi-wires, and this is when you add OBN to it. Look at that difference. So, unfortunately, we need the seismic companies to have an investment model where it makes more sense to spend money in Mexico. But it may not be the geology that's gone wrong. It may be just we've got to get wells in the right place. Is there anything in the geology that looks different? Well, subtly there is. Here's a cross-section from the GOM, north into the south and deep water. Here's mine and Hussein's cross-section for Sureste. Looks pretty similar, big canopy. Things coming up involving the source rock. But there's two subtle differences. The first one is the canopy is at a different level in the southwest Suresti Basin. It's shallower below mudline. So if you're struggling to see beneath it, you're left with pools above it which have DHIs all over the place, where they've got reservoir pressures of 2,000 or 3,000 psi. They're very shallow, they're small, and by the way, you need to go and look for hub-class opportunities, so that doesn't work very well. And you haven't got the seismic technology to image for that. So I think the amount of berry, where the canopy is shallower in a lot of Suresti. Zama was a big field. Is there anything funny about Zama? Well, actually there is. Zama sits on the edge of one of the big tertiary troughs. So part of its kitchen is much deeper than the sort of shallow, lot of Suresti, which is shallow structures with shallow salt. So Zama sits on the edge of one of these big tertiary troughs. There's other discoveries that Wintershall have made where, again, chasing stuff around the edges of the troughs allows you to put kitchens, in proximity for super salt or traps where you can see the flood spots. The other awful thing, it's not awful, but the other difference is that there's an Eocene detachment surface. There's a big overpressure shale in the Eocene in the western part of the Suresti Basin, and then you've got a problem. You haven't got deep charge focus. So you don't want to be anywhere where the Eocene detachment is. You want to be inboard of that. So you get your Jurassic source rocks under your reservoirs. But, what about all of this stuff under here? Why wouldn't it work? And see geologically why it wouldn't. Someone says, it's because you haven't got the big major river system, you haven't got the Mississippi. No, you've got smaller systems, but you're in a tropical climate, and it rains every day in Villahermosa, and that's what the river looks like. There is sediment pouring off that. And we always wondered whether if you went in the Zama's late Miocene, and it's more quartz rich, we always wondered if you went in the early Miocene, did you just have really bad sands? No, you don't. Pollock is early Miocene. It's fine. You've got more clay content, you've got more feldspar, your rock properties are more complicated, but actually you've probably got the porosity and to a certain degree the permeability that's there, it's going to flow. It's just different. The Murphy's discovery offshore Brunei looks just like this. There's no major river system, but there's just a ton of sediment coming off because it's a very tropical environment. I'll leave this one. So when I think about the South, it's a simple fact that we've got a completely different level of technology to play with here in the GOM. And that's allowing us to keeping this subsalt train of discoveries going. And we understand the seismic rock properties really well. Binary, sand, shale, clean. Not a lot of ash, not a lot of feldspar. It kind of all comes together, and you've got so much calibration, it's not true. And guess what? You're looking for smaller things so you can make those commercial. That's different. You haven't got the wells drilled, you haven't got the calibration, you've got to find bigger things to get them commercial. And we've got a problem with imaging. I don't necessarily think that means that the petroleum geology is wrong. I just think you've got to be able to see where to drill. And there was, a couple of wells recently, one of which you were involved in, I think, we found a channel system, a beautiful sort of sediment corridor. You get the well, and it was thin-bedded turbidite or something, and it wasn't the channel sands you were looking for. You just didn't have that image to place the well in the right place. Sort of a shot point risk issue. And I still think the industry needs to get after mesoseric carbonates. There are shallow marine carbonates offshore, way offshore, on old highs, with Kimmeridgian sands, Tithonian sands, cavernous porosity. But not many companies want to do that. They haven't got the DNA to do it. So, I think the geology is still there, but it's lacking a lot of seismic technology. and there are other surface issues with investing, which we kind of all know about in Mexico. So what do we do beyond that? Disruptive discoveries, you should be able to think about that on a global scale. There's Namibia, there's the Santos Basin, there's Guyana. This is all to me on the passive margin of the Atlantic, specifically the southern Atlantic. And there's an enormously fantastic source rock in the early Cretaceous when that thing, a big lake basically, that made the thing work. We can play that. I mean, some people would call that being a fast follower. You find the recipe here and you apply it elsewhere along the margin. You do exactly the same on this side, and a bit of thinking about heat flow, you can go way down deep towards the oceanic crust. Fallen basins. I work Venezuela. I've always wanted to work the Barrow Arch in Alaska, which is a bit more buried. Most of those I think are off limits today, with the exception of the Barrow Arch in Alaska. That's got to be a great place to go. So fascinated if we could, that would be a great place to invest in. And then there's the other margins. There aren't a lot of wells being drilled on active margins at the moment. Transform margins aren't particularly well understood. They work locally. Honduras is a good example of that. One thing I know from living in Costa Rica is 3 hours drive from my house is the richest source rock in the world, the Lomo Chimilco, Upper Cretaceous source rock. 1,000 feet thick. Parts of it are 33% TOC. And it's completely white in the outcrop because the carbon burns off in the sun. I mean, it doesn't say light, but that carbon just disappears and becomes a white crust. So if you're going to go and look for active margins, being on a place that has upwelling and lots of great source rock potential, I kind of like that. And it's not what everyone else is doing. So, I think there's interesting percentage. There's an interesting idea of going to different margins than just the classic margin, passive margin, going forward. I got one more. Okay? So I gave this talk. I'm doing this talk. This is my third time, I think. And at the second talk I gave at the Deepwater Symposium, I got a question at the end, which is all about, Mark, this is all well and good, but I work in a big oil organisation. How the hell do I become a rebel? How do you introduce a new idea if you're working in a company? I think it's more straightforward than you think. There's two ways to look at risk. One of them is to think, and you can put this on a sort of funny matrix. This is high risk, this is low risk for each of the components we're used to seeing. You can say, well, I'm going to be a very geological model. I'm going to say, hey, I've worked in the US GOM for 30 years. This is how it works. This is the acre foot at this level, blah, blah, blah. And that's being geologically model driven to my way of thinking. Or you can collect as many observations as you can and find the outliers. And that's being observation driven. So can we go and do that? Can we collect data and use that data to argue a case? Let's say I'm, 5 years into the industry and I'm presenting to my CEO with 35. He's a good scientist, he'll listen to data. Of course we can collect data. We can collect data on just about each element. Reservoir presence. Bob's doing a whole bunch of stuff, tying seismic to wells using rock dock. What should wet sands look like? What should oil sands look like? What do shales look like? We can do the classic deposition environment maps. Reservoir deliverability, there's lots of data out there on core permeability, mobilities from MDTs, rock strength. All of that data can be collected to de-risk that element. Seal capacity is all about effective stress. Lithostatic minus reservoir pressure. Massive amount of data to collect that. Trap, analogs, salt wells, how many times do they work, how many times do they fail. Andy Pepper is doing a fantastic piece of work with his Acme idea. So don't think of just a late Cretaceous source rock and a Jurassic source rock. Really big, granular. What are you talking about? How many stacked source rocks are there? What is each for one? What is its expulsion efficiency over square kilometre? And then we've already talked about heat flow. There's something about hydrocarbon phase you can get from mud gas analysis. So what I'm trying to say is, if you work this way, probably a little bit better than you work that way, you can get a long way to de-risking it. But you've got to put a lot of databases together. You've got to be really granular about that. And I guess that's what I would advocate. That's what you need to do. And obviously, because that's in there. And until you put that stuff together, I don't think you can make the key observations that take you from here to finding that next piece. Risking. I have no idea why we multiply these together to come up with a risk number, actually. I don't see the logic in that. But I do know that I'd rather do prospects which has just got one risk in the middle. If I start having trap and access and seal capacity all sitting in here, I've got a problem. So identifying the key risk, structuring your work program to understand it, is probably the thing to do. You know, none of us have a portfolio of hundreds of things, so you just want to know what are the top 3 things we're going to do, what are the stuff that's never going to work, that's got 2 or 3 things in here, and you know, what things do I need to work further. And I think this is an interesting idea. Is, you know, no one is really entitled to have an opinion per se, and just call it a day. This is never going to work. Thank you very much. Stop. We're scientists. It should be backed up by this type of work. If your prospect relies on a strong geological model, you better go and get the expert who knows about that. You know, we looked at Denali's charge axis was the key issue. We sat around as a team. We couldn't really get to a number. Hey, Andy, come and have a look at this. Andy Pepper. And that's kind of it. So I think, unfortunately, there's a lot of work. But that's kind of cool. We should be doing that. And we should name things we're looking for. So in Westlawn, we had this idea that there's a string of pearls, amplitude-driven subsalt things, which lie around our infrastructure. Of course, we're going to do a bunch of those. You know, if I was presenting to Neil, it would no longer become a string of pearls, it'd be a can of worms, but I understand that, please. But we're going to do that. But we have named this idea that we want to go after disruptive discoveries as well, things which will transform the value of Westlawn. And sometimes by putting a name to it, it's in the DNA of, I'm going to do part of that. Be it as a fast follower, chasing Guyana up south or to the other side, or be it in looking in a completely different margin setting. I hope that was fun. Trying to do it. I'm not the greatest dinner speaker. You know, theories crumble, but good observations never fade. And you know what that is? Any Star Wars fans? The Rebel Alliance, the latest Star Wars thing. So, probably that's my next tattoo, I think. But I need to get through this year and at least not drill 3 dry holes. I don't feel like doing it so much. Thank you very much. For sure.
So you'll do that next year?
So, how many people like to talk about the dry holes they've drilled? I mean, I don't. I do feel ownership over missing Zor. And I saw the damn thing, but I didn't speak up. One of the wells Sierra proposed and then was subsequently drilled was a big early structure of the Soresti Basin, and it relied on having shallow water fascies on the top of it. It wasn't deep water fascies, but it was drilled quite a long way down to it. But of course it was a dry hole, so that play was not really given life past that. So I think there's lots of that. And how many wells have been drilled and just missed the channel, you know? Well, when I had the worst year of our life in Egypt, we were drilling a development well called West Arkin 2, and we were drilling on a seismic survey, we could see the channel, and then we got a new survey in as we were drilling the top hole, and the channel had moved on the new velocity model. And we looked at each other and we went, do we rock the boat? Yeah, we were out by 100 meters. A second, well after we left, 100 meters away, found exactly what we were looking for. So that's there. And it's, it's not for everyone doing this sort of game, because you're going to be humbled a lot of the time. And just really looking for the insights that in that is got to be key, isn't it? So yeah, I'm completely with you. And that's again, so you want a database of dry holes. You want to have not only the CNC success analogs database, but you really want the equivalent in dry holes and why they were dry. I think a lot of it is down to shock points, actually. I think that's certainly true in the Southern Continent.
Explorationists can be optimistic, but managers tend to be...
Explorationists can be optimistic. They can be... Well, I'll tell you one thing on that. To answer that question without really answering it is, what are you risking? It makes a big difference if you're risking the mean case, which is economic, as opposed to are you risking getting on the curve? So I've known a company where they were asked to risk either the P99 or the P90, and I think it was the P99, and the company philosophy mandate was you had to make your P99 2 million barrels recoverable. So why are you risking that? There's a disconnect straight away. Geologists don't like to fail. And that tends to drive you into a really weird risking philosophy as well. It's difficult to get exploration prospects near 50%. But if you're multiplying together 6 components, how easy it is to put 1 against 3 of those components. As soon as you put 90 times 90 times 90, you end up at 6 times. Take 0.9, that's as high as you could go. 6 times that is 56% chance of success, so that's not real. So I think it's about thinking about what are you doing and making sure you're risking an investment case, you're not risking an unreal case. As soon as you do that, you get a disconnect. And then, hey, you're finding oil, but it's so uncommercial, it doesn't mean anything. And then management doesn't start to trust what the explorers are trying to do. I don't think it's about explorers being more optimistic. I just think you can be driven into doing strange things. Does that make sense? A little bit?
Maybe.
So, Patty Walker, I enjoyed your talk. So in reality, there is a difference though between geological risking and economic risking. And understanding both is important. Because your dry hole data set is probably going to be more off geologic risk because economics are company dependent. And understanding that gap between what's potentially there geologically versus what could be economic can be huge. And there's value in that.
Of course. Yeah.
So the company I worked for, that was one of the things we worked really hard on, was being able to explain all of those. Here's geologically what's possible, but here's where the economic part sits, and that gap can be important. So I appreciated your comment about you need to understand dry holes, right? Because the only way to understand what's going to work geologically is to know what failed, and then what's the odds of that, and then between what I can discover, which may be 4 million barrels, that never makes money, we're not doing it. So that gap is huge, and I know BP had a very similar philosophy.
Yeah, we did the same thing. We had a crystal ball shop, and
Right.
what is your minimum economic threshold? You cut that off, and that becomes another probability you put in.
Yeah. but all of those
But-
matter. And management sometimes struggles to understand the difference between those.
But I think it's a different thing when you're being asked to risk something that's P99 or P90 as a as a culture. That can lead to a bigger disconnect.
I totally agree.
Yeah. And for discovery things that reset creaming curves, and I know I'm being selective, it's less of an issue because they tend to be the bigger things you're going after. The can of worms type string of pearls thing, yeah, you've got to be really clear about where your commercial capital's off. Thank goodness we can tie back things to infrastructure these days, which are really small by comparison to a lot of the parts of the world. Back at it.
So Mark, you mentioned the word culture. Can you talk a little bit about, there are some companies that have discovery after discovery after discovery. In your experience, you've been in some really successful teams. What are some of the key components of a corporate culture that breeds giant discoveries?
I wish I knew how to really answer that, because I think it's my bias that would start to answer it. Companies with lots of layers don't help data-driven answers come forward. I think that's a very superficial thing to say, really. I think it's very useful to have senior leadership who are themselves, explorers or oil and gas. They have that in their core skills. It's not a numbers game. It's about finding oil first of all, and then monetizing it, and then developing it. And I suppose the other thing to say is, if you have the skill set where you've seen a lot of basins, you don't really have to reinvent the wheel. You just have to apply one learning from one part of the world to the next. And that's about timing and being in the right place at the right time. Bob and I were in India drilling below a depleted gas field, which was in a channelized system, and we were drilling across these tilted fault blocks offshore east coast of India. And the seismic processing, we could see hints of a flat spot. And Reliance, who we were working with, they had a 30-person in-house processing team. So by the time Brian Barley, who was working with Bob on that, by the time they got that flat spot pre-drill ironed out, it's like a knife. And it cut across the stratigraphy. And I left BP Reliance, and Ivan called me to Mexico. And in round one, we were looking at this tiny postage stamp bit of seismic on this fault block. Guess what? There was a cross-cutting reflector. And that was the key observation. Just because I'd seen it 6 months before in India, I applied it. I said, well, that's what we have here. And it's not a base canyon cut. It cuts across the stratigraphy. And I guess that was the first observation that led to Sama becoming what it did. So yeah, I don't know if that answers part of it.
Yeah, those are two good points.
And I think, the third point is, it's quite difficult as in lead. For me, because I'm leading a tiny little team, but it can be difficult for leaders to listen to data. It's difficult to summarize things down into 2 or 3 slides, and it takes a certain mindset where you really want to listen to someone go through the geology, sit around on the workstation and do that. And hasn't that got to be a core skill at a sort of CEO level or COO level, to be so curious, to wanting to sit there and go through it? I think that's, I think that's a key discriminator as well. Neil?
You sort of went down the road of observations that dendrites are important. You went down the road of saying that dendrites are important as your reservoir type. observationally, is that what you saw in Zama? It's a debrite? I mean, clear evidence that it wasn't, you know, deposited as a turbidite, that it was slumped and messed up. Generally,
So,
right?
I kept very quiet as it was post-drill. I knew it wasn't in the channel because I'd worked with seismic. You know, Tars, you know, the people working with thought it was a deep water deposit. And then my last job, before Sierra was sold and I became an interim asset manager for Zama, which was a fantastic thing because it gave me the excuse to go and look at 300 meters of core, 1,000 feet of core. So I went through the whole, we cored 2 wells extensively and full of injection structures, boulders in it. They're difficult to carry in turbidites. And it had a ichnology, it had microfossils which were clearly in parts shellful. And that doesn't make it an organised turbidite to my mind. I'd also been lucky enough to work Harding in the North Sea and also Happy in the Egypt, which are both sandy debrites, these submarine landslips. And they just go down a bit and lock in place. And they have the same features. So I was present.
You can tell the difference between the mobilised sands and the debrites, is what you're saying.
I think you can, and I think unless, and I'm really delighted to be proven wrong, but I think you see more thixotropic behaviour in things that freeze in place just off the shelf because they inject and they're depositional form. So that's what I saw. And it's very inboard in its setting. And we know that because we end up with a bunch of seismic. We could see all the channels kick off down deep, you know, to the north of Zama, not inboard with it. And that's where we do Apollo connection, or you guys do Apollo. So yeah, I think it is. So that means there are thick sands in places locally in the upper slope setting, which you've got, you know, they're not everywhere at all, they're very local. And you need to be able to see that depositional form before putting a well in that type of part of the play fairway.
Just follow up with what Neil was asking. It's 1,000 feet, you mentioned that this thickness is 1,000 feet or 300 meters. Is that the entirety of one debrite event or multiple events?
That's a great question. 200,000 years was the time it took to deposit 1,000 feet of sand. If you look at the biostrat from below Zama or right at the base of it to the top sands, there's not much there. There's some a little bit of, I think, nanoplankton data that is a very, very quick deposit. I would imagine it's multiple. But I think it's a good question. I need to think about that some more. If you look through so everything's in pressure communication, but if you do an overpressure plot, there's a slight step across one shale, which is 30 feet thick. So that probably implies that at least 2 events. There's some ash beds in between, which are continuous in 2 wells. So it's got to be more. It's got to be more than one. But I don't think it's in 1,000 meters of water and an organised turbidite system.
Thank you, Mark. Just like my point here is about like these disturbing discoveries is things get comfy sometimes in working on basins, following just like theory and try just like to find discoveries. The point here is like usually, or does this comes like disturbing discoveries comes with like new thinking out of the box, newcomers to the room, or how does that work? Like, because sometimes when it gets stagnant, it's very difficult to think outside the box or rearrange your thoughts, right?
Sure. You don't find much oil looking in an old basin with old ideas. Simple quote. But a new idea doesn't mean that you're an Einstein. It just means you may have seen that idea somewhere else. You apply it to the new basin you've worked. But I think going out and collecting ideas is a really key thing. I want to attend conferences. I want to take part in GeoGolf. I want to hear other people's stuff. I'm going on a Mike Hudek's salt field course in May. Because I'm not going to find those new ideas just spending each day at my workstation. I've got to do some other stuff as well. And when I'm not being told by a van to do something by Tuesday, I still go, well, where's that pressure data I haven't got in my database yet? Or have I got some core data I need to add and keep adding to databases? And of course, I encourage people to do the same.
You should have. Greg is the one who asked you that. I never said.
No. You ask more thematic questions. So look, thank you very much. I appreciate the patience. And, it's very good.